This is your Day 1 Introduction to Dimensional Analysis lecture. So in dimensional analysis, what we're really going to be doing is comparing units and converting units to other units. In order to do that, we have SI units, which are a set of units that the scientific community has agreed on and can use across the world to make comparisons and experiments. So there are 6 here on the screen that you can see right now, but those first 4 are the most important. These are the ones we are going to ask you to memorize. Time, length, mass, and temperature, we're going to be using them a lot throughout the year. Time, your base unit is the second. You can abbreviate it as either S or SEC. For length, your base unit is the meter. The abbreviation is M. Mass, your base unit is actually a kilogram, not just a regular gram. A kilogram has a symbol kg. And for temperature, it's a unit that you might not have heard of before, the Kelvin, and actually is the capital K. We're going to deal with temperature a lot more later in the semester. Those are the 4 you have to memorize, so please start memorizing them now. So dimensional analysis is the process in chemistry that we use to show the work of conversion between units using conversion factors, right? You know already that 1 foot is 12 inches. You're going to learn about prefixes here in just a second. So if I gave you something like 2 minutes and I wanted you to convert that into seconds, you could probably do that in your head. I'm sure your thought process is something along the lines of, okay, for every 1 minute, that's 60 seconds. So if I have 2 minutes, I'm just going to multiply that by 2, and I get 120 seconds. But most of the things that we ask you to convert in chemistry are not going to be something that you can just do in your head. What if I instead asked you to convert millimeters all the way to miles? There is no way that you're going to be able to do that in your head. Instead, what you're going to have to think about is where you can go from millimeters. Maybe you want to go to meters, so you'd need to know that conversion. Once you go to meters, you might not know how to go straight to miles, but you will soon know how to go from meters to kilometers. Once you're in kilometers, we are going to give you a conversion that would then let you take kilometers to miles. That's not the only way to convert meters all the way to miles, but it's a process. Dimensional analysis is the way we show that process and show the work. Showing that work, we use conversion factors. You probably have at least some idea of what a conversion factor is. It's a relationship between 2 different units of measure that really mean the same thing. So 1 foot is equal to 12 inches. You can write that in 2 different ways, with either feet on top and inches on bottom, or flipped, inches on top and feet on bottom. This is effectively the same thing as this, because you're multiplying and dividing by 1. Because these 2 measures measure the exact same thing, how you write them depends on what units you're trying to convert and get rid of, which you're going to see in just a second when we go through the process. As far as significant figures are concerned, all conversion factors are exact numbers. In 1 foot there is exactly 12 inches. So it's not that there's 1 sig fig or 2 sig figs. Both of those would have an infinite number of significant figures, so they're never going to limit your final answer. Any conversion factors between English and metric units will be given to you. You do not have to memorize anything that you see there or any other English to metric. I promise, no memorization of those guys needed. What you do need to memorize, and everyone will have to memorize this, is milli, centi, and kilo. 3 conversion factors, 3 prefixes that you can use for everything. A kilo is 1,000 of the base unit. So 1 kilogram is 1,000 grams. 1 kilometer is 1,000 meters. 1 kiloliter is 1,000 liters. Kilo is just a preference. You can throw it on literally anything. 1 kilo wazoozle is equal to 1,000 wazoozles, right? It doesn't really matter what unit you put it on. Kilo means 1 or 1,000 of the base unit. Centi is similar. It just means for 1 base unit, you have 100 of the centi units. So 1 gram is 100 centigrams. 1 meter, 100 centimeters. 1 liter, 100 centiliters. Again, just prefixes. So as we get to dimensional analysis, you might see that listed as 1 gram is 100 centigrams, or 100 centimeters in 1 meter. Centi just means 100. Last one you have to memorize is milli. Milli is like kilo, just the opposite direction. It's 1,000, but it's 1,000 of the smaller unit. So one base unit, 1 gram, is 1,000 milligrams. Milligrams are smaller. 1 meter is 1,000 millimeters. 1 liter, 1,000 milliliters. Again, the whole idea here is these are prefixes you can throw on any unit to start converting from one to another. The other one that you do need to know that we'll use every once in a while, it's on the rarer side. 1 milliliter is equal to 1 centimeters cubed is equal to 1 cc. We really never use cc's. So also just remember that 1 milliliter is 1 centimeter cubed. So to do dimensional analysis, here's a series of steps. You're going to start with what you are given. If you are given more than one thing in the problem, you're going to use the number with a base unit, not a derived unit. We're going to talk about derived units in tomorrow night's lecture. You're going to figure out where you want to go. So essentially you're starting with figuring out where you're starting, you figure out where you end. Then you're going to make a path using conversion factors to convert from one unit to another. You might not be able to do it in one step. That's fine. Just do it in multiple steps if you need to. Make sure everything you don't want is canceling out. Write in your units, and then do the math. And then you worry about sig figs at the end. So seeing the instructions being read, having them read to you is one thing. Let's actually see this in action. So, example number 1, I want to take 57.98 milliliters and I want to convert that into liters. And maybe you can do that in your head, but we're going to expect that you show us some work. So step 1, start with what you're given. Well, I'm given 57.98 milliliters. Step 2, figure out where I'm going. I want to go to liters. So I'm going to set up my dimensional analysis. Some people call these railroad tracks. But there's a few different names for them, but this is kind of what we'd expect you to do. And I have to think, do I know a conversion from milliliters directly to liters? And it's one of those three you're going to have to memorize, milli, right? I can go from milli of a unit to the base of the unit. So I have milliliters, so I can go to regular liters. And my conversion factor is that for every 1,000 milliliters, I have 1 liter. I have a milliliters on top. That's going to cancel my milliliters on bottom. I'm going to be left with liters. So I've done step 4. Make sure that the units I don't want cancel. Time for math. 57.98 divided by 1,000. Everything on top gets multiplied together. So 57.98 times 1. Divided by everything on the bottom. Well, in this case, there's only one thing on the bottom, 1,000. So you'd have 57.98 divided by 1,000. Gives you 0.0555798 liters. Your units would be at the end. I just can't write that small to fit in the blank, but I have 0.05798 liters. Let's look at example 2, because that's that example we talked about earlier, going all the way from millimeters to miles. So step 1, think about where you're starting. I'm going to start with millimeters. Step 2, think about where you're ending. You want to go to miles. So I'm going to set up my dimensional analysis. 5,005 millimeters. Start my railroad tracks. And I don't know a conversion directly from millimeters all the way to miles. But if I look, I know that if I can get to kilometers, I can then go to miles. But I can't go from millimeters straight to kilometers, but at least you see kind of meters and meters, so that's a good clue that maybe my first step should be going from millimeters to regular meters. And we know that conversion. It's one of the ones you're going to have to memorize. 1 meter is 1,000 millimeters. Then in your next step, you can say that for every 1,000 meters, there is 1 kilometer. I'm going to shrink this so we can get it all on one page. Then you can use that third conversion factor up in the top. For every 1 kilometer, you have 0.621 miles. Everything that's on the same on the top and the bottom can cancel. I got millimeters, I got millimeters, I got meters on top, I got meters on bottom, I got kilometers on top, kilometers on bottom, and the only unit I'm left with is miles. If I look back at the problem, the only unit I wanted at the end was miles, so now it's time to do math. Everything on top gets multiplied together. 5,005 times 1 times 1 times 0.621, so all of that gets multiplied together, divided by everything on the bottom multiplied together. So you can use parentheses when you type this into your calculator. So you get 5,005 times 1 times 1 times 0.621, parentheses, divided by, new set of parentheses, 1,000 times 1,000 times 1. Which, when you type it all into your calculator, will give you 0.003108105, but that's way too many sig figs. The rule of thumb that we're going to let you use for dimensional analysis is look at the number of sig figs you start with. That's how many sig figs you can end with. So if I started with 4 in my initial number, 5005, those are both sandwich zeros, I want to round my final answer to also have 4. So 0.003108 miles. Right? Those first zeros are leading zeros, so they don't count. That 0 in the middle is a sandwich 0. It has to count, which means then I can round the 1 down and end up with just 0.00318. Sorry, 0.003108. Let's do a couple more examples just so we can kind of get the hang of this. First one, 6.23 kilograms, and I want to take that to centigrams. So step 1, figure out where I start, 6.23 kilograms. Then I got to think about where I want to end. I want to end centigrams, but I don't know a conversion from kilo all the way to centi in one step. But remember, I don't have to do this in one step. You can go from kilograms to the base unit. You can get rid of the kilo and just go from kilograms to regular grams. If I have kilograms on top, I'm going to want to put kilograms on bottom. And I know my conversion for every 1 kilogram, I have 1,000 grams. Once I'm in grams, then I can go down to the new prefix, centigrams. For every 1 gram, I have 100 centigrams. I think I'm at the error because I wanted centigrams and I have centigrams now, so I'm going to make sure my units cancel out. I got kilograms on top, that's going to cancel out kilograms on bottom. I got grams on top, that's going to cancel out grams on bottom. So I'm only left with that unit, 1 centigrams. Now I'm going to do my math. Everything on top gets multiplied together, divided by everything on bottom multiplied together. So I get 6.23 times 1,000 times 100 divided by 1 times 1, so I'm just really dividing by 1 here. So I take my 6.23 times 1,000 times 100, and I'd get 623,000 centigrams. Right? I started with 3 sig figs. I end with 3 sig figs as long as I don't put a decimal there. Last one, example number 4. I want to take 3.4 liters and go all the way to centimeters cubed. Now for this one, we have to remember that one special conversion. For every 1 centimeter cubed, I have 1 milliliter. Now I can't use it right away because I don't have milliliters yet, but I do have liters. So I know my first conversion can go from liters into milliliters. And I'm going to show you this one without putting any numbers in first. I can go from liters to milliliters. I got liters on top, so I'd want liters on bottom. Then in my next step, I can put my milliliters on bottom because I have milliliters on top in the first step and go to centimeters cubed. So you don't even have to know these numbers in order to figure out your pathway. And for some of y'all, this might be a little bit easier way to approach it. Think about your units first, then go back and start plugging in your conversion factors. For every 1 liter, you have 1,000 milliliters. For every 1 milliliter, you have 1 centimeter cubed. Then you can cancel out your units. Liters on top cancels out liters on bottom. Milliliters on top cancel out milliliters on bottom. I end with centimeters cubed. Time for math, 3.4 times 1,000 times 1, right, everything on top multiplied together, divided by everything on bottom. So really I just get 3,400 centimeters cubed. 2 sig figs, 2 sig figs. Please get some practice in. You're definitely going to need this skill. We're going to be using it for the entire year. We went through this kind of fast, which definitely means when you come to class, you need to ask some questions. Make sure that you're able to set these up correctly, plug them into your calculator correctly, because we're going to be using dimensional analysis all year.